Welcome everyone. This video we're going to be covering more on the power transfer method, where we have a series bank of batteries and a parallel bank of batteries and a light, and instead of in a conventional or normal sense of using this light, we would run the positive into the light. I mean, it's got its own light battery set up in the back, but the wiring would be positive and the negative are connected to that light, and the power would be depleted, generating heat, and you get one run. Everybody is familiar with that method of operation, whereas in the transfer method, I am claiming, and many others, this is not my invention, I might say it's over 100 years old. This concept is over 100 years old. So with this method, the transfer method, the power would go through the light and then be stored here in these batteries in the parallel bank set. It is not 100% of the power. Not 100% moves through the light and to the batteries, because the batteries have their own internal resistance, so they literally discharge all in their own, not even being in a circuit. So that's just how they operate. So you can't expect, it would be like having this, say these are two water tanks. The serial battery bank is a water tank that's drained into this water tank, and imagine if you had one hole in this water tank, that would represent the internal resistance of the batteries. So you're going to have a small amount of water / electricity dripping out the base of this water tank / battery bank. Okay, so it was pointed out that the amperage consumption when measuring it and comparing conventional to the transfer method, that the reduction in amperage was largely due to a drop in voltage. This I was already aware of, but it's important that someone's commented that that's the case, and they were correct, and I felt it's important that everyone understands that same situation. So here what we'll do is we'll demonstrate. So normally I use, in the past couple of videos, I've used 4 batteries in the series bank, and that has given us 4.8 volts. These batteries are 1.2 a piece, so that gives us 4.8 volts. Now, when using the transfer method, the parallel bank is seen as a minus on the voltage. It is a minus to the total voltage of the serial bank. So in that instance, in the previous videos, this has been 4.8 volts minus 1.2, giving us 3.6. So when I ran it in the conventional sense or normal sense, we just use this serial bank, and that would mean that we have that higher voltage, 4.8 volts instead of the 3.6, because the resistance seen by this bank of batteries has that reduction in voltage. So I'll demonstrate that now. So we've got the series bank here, and here at the base of the screen we've got this white cable that goes to the multimeter. Now the red positive side there, I will connect on that cable. So in the past, so if we just check this voltage first on just the serial bank. So if we connect there, that's the 4 batteries. Alright, and they're charged, so they have a slightly higher potential than if they were under load. So this voltage would drop down drastically as soon as you connected the load or the light. So 4.8 volts, so that's showing that that's correct. And then if we go to, so add in the extra battery, the 5th battery, and the reason for doing that is to give us the same voltage as the conventional sense. So in the conventional sense we had 4.8 volts. In this transfer method, if we were to only use the previous 4 batteries, we'd have 4.8 minus 1.2, making 3.6. We add in an extra 1.2, making this 5. What was it before? 4.8, 5. Yeah, so that'd be 6 volts across those 5 series batteries. So if we now connect to this one here, you can see on the screen that would be the serial batteries, all 5 of them, giving us the 6 volts. And again, the 0.6 is purely potential. If we were to add the load in at this point, we would see that difference. Now what I want to demonstrate is the voltage between the 2 sets to show you that it's serial bank minus parallel bank. So if we take the white jumper lead, and when you're using the transfer method, the serial bank becomes the real positive. Okay, because if you look at it here, we've got serial bank positive line and parallel bank. I know it's a bit messy, I'm sorry. Parallel bank, if we just push that out of the way, we can sort of make that a bit clearer. You can see all the parallel bank batteries have been connected together there at the top. So the parallel bank becomes negative, so we'll place that on there for the negative. And then the serial bank positive becomes the true positive. So we put that on there, and we can see it's a 5.28 volts, as opposed to when we connected these batteries, all 5 of them together, it was 6.6 volts. So if you do the calculation there, that's almost spot on. That reduction is this voltage that's seen on the parallel bank. So serial bank minus parallel bank. Okay, I think that's pretty clear. So what I'll show now is we'll place the light into the circuit. And so if we go for the transfer method straight away, this yellow here is the negative, so that goes on the parallel bank set, and the green one in this case is the positive for the light, and so that would go on the true positive coming off the serial bank. Now I suppose if we go straight away, we'll go to what it used to be, the 4. It's a bit hard for you to be able to judge the difference on the camera of intensity, but that's less because we're running off of just the 4. So we push that one to the side. You see I've joined it there prior to that battery, and that's open circuit there. So that's how it used to be connected. And if I try and keep that on there and we connect it to the extra battery, you can see there's an increase in brightness there because of the increase in voltage, making it more similar to the conventional or normal use, where we have 4.8 volts going across that set. So if we now check the voltage across the actual load, so we go to the true positive off of the serial bank, and we go to the negative, which is the positive of the parallel bank, and then we can see under load we've got 4.37 volts. So that's what's expected and that's reasonable. So what I'll do now, just quickly, I'm going to do some amperage tests in a second here. So what I want to show is, for those who are a little bit confused about why we would want to do this, in my opinion, it's recycling your energy. We don't get all of it, as we discussed, but getting some of your energy back is just flat out amazing, in my opinion. You've already paid for it. You may as well use it as many times as you can, and so we can recycle this power as many times as the potential voltage will allow that to occur. In each scenario it's going to be slightly different. So if we connect up, so positive to what would be the serial positive or true positive, and what I want to show here before I connect the other side, which is the parallel bank, I want to show the voltage, and so we'll connect the voltmeter just to this parallel bank, and we want to get a reading on its voltage as it currently stands, and then we'll be able to demonstrate when I connect this yellow wire, engaging the transfer method. So power comes out of these batteries, flows through to the load, out of the load, and back into a parallel bank of batteries here. And what we'll see here on the meter is the voltage will slowly start to rise. Okay, so here we go. On, lights on, power's being transferred. So again, not all of it. The higher efficiency of your batteries, the higher quality batteries that you have, and that does not directly relate to the more expensive batteries. It's just the higher quality batteries, better batteries. More expensive is not always better. Don't be fooled. So I get similar results from cheap batteries and vice versa. There might be some difference in longevity of runtime, but this is the type of system that you would drain this within 24 hours. You would the best method for use and the best method for looking after your batteries is to change this over, say every 12 hours would probably be best. Even every 24 hours. Say you just did this once a day. You took your batteries, and you're leaving this light running, by the way, during the daytime as well. So it makes it extremely efficient. You're not using that power, you're transferring it. And then later we just repeat the process. And, you know, each battery set will need to be tested to determine how many times you can actually do that function. And, you know, one of my tests, which probably wasn't healthy for batteries, I ran for 275 days, but I was trying to see what the limits are there. My recommendations for this would be every evening, you know, just before it gets dark, take your parallel batteries and place them in the series position and vice versa, and then repeat. And then tomorrow afternoon do the same thing again. And say even if you get a week, then that's 6 days more than what you could have possibly obtained using the conventional method or normal sense of using electricity, where we run positive to negative on the battery bank, depleting that power. Energy can't be destroyed nor created, but it can be transformed. And so in this instance, in a normal conventional use, the energy that isn't consumed to produce the light, so the energy that is not transformed into light, is transformed into heat, because it has nowhere to go. It can't be destroyed, so it must be transformed. And that's what it sets about doing. It transforms itself into heat. So a conventional use of electronics is abusive towards power, and using this transfer method instead of creating unnecessary heat, unless you want a heater, great, but you know, that's the practical sense of conventional electronics, is they're bloody heaters. Stupid. A stupid way to go. This is not by accident that you don't know about this. This is by design. So I'll cut that short here. You can see that the power's still going up. And then I'll do some other videos on amperage. What's the difference between the transfer method on both sides of the load. Obviously I'll do those separately so I don't offend anyone with Kirchhoff's law, which I still question the relevancy of. It's up for debate in my opinion. I've seen so many things, I just tend not to follow the rules anymore. I don't think they work in our favour. Alright, thanks for subscribing. Please like, share, and if you haven't already, subscribe. And check out my other videos if you could, and teach someone this. My main goal here is get this information out. So there'll be more tests on this, in coming weeks. Sorry to those of you who are bored and want to move on to things that go bang. We'll get there. I've got a lot of things that I want to show that are so simple that everyone can do. And unfortunately that's just going to take time, working with my poor health and lack of motivation. But I'll get there eventually. Alright, thanks everyone. Have a nice day.